In this lecture, I will talk about energy in water. I will talk about different forms of energy in the water and how each form of energy gets transferred into another form of energy within the water. We will also study how we can quantify each form of energy, and we will be able to find out how much is the total energy inside the water. Finally, we will also study about energy flow that is happening inside the water. Energy flow per unit time, we know that it is power. So, we will also study about power flow in the water also. So, before we delve into the real topic, I will first talk about the basic unit system that is being followed, that will be followed in this course. The first quantity is mass. The unit that is normally used for quantifying mass is kg. Next quantity is weight. Many times people get confused between mass and weight. Mass and weight are two different quantities. Mass is different and weight is different, but they are related with one another. Weight is equal to mass into acceleration due to gravity, and weight is a force because mass into acceleration. So weight has a unit of kg meter per second square, and 1 kg of meter per second square is called, in memory of the great scientist Newton, it is called as Newton. So fundamental unit for weight is kg meter per second square, or for force kg meter per second square, and derived unit is Newton. Next is force. Next is work done. Work done, we all know that it is force into distance. So, for instance, let us assume that there is a mass of 10 kg and it is at a distance of 2 meters from the land surface. So, when a mass is allowed to fall from here to here, what happens is a force is continuously acting on this mass. What is the quantity of the force that is acting on this mass? That is weight of that mass. So weight of this mass is 10 into 9.81. So distance of fall is 2 meters. So continuously a force is acting on this mass for a distance 2 meter. Hence work is done when this body falls from this place to this place. That is what is work done. And now that we are able to quantify how much work has occurred because of this mass falling from this place to this place, and this is equal to 10 into 9.81 into 2. And for all our board calculations, we will use, instead of 9.81, we will approximate this to 10. So 10 into 10 into 2 is 200. What is the unit? The unit is Newton meter. So So for work done, the unit is Newton meter, and in memory of Joule, scientist Joule, 1 Newton meter is denoted as Joule. So we can say that it is 200 joules. 200 joules. So next concept is energy. Now 200 Newton meters of work has occurred, and this work has been stored as energy in the body. So before this work was done, this amount of work was stored in this body as energy. That energy is called potential energy, or datum energy, or gravitational energy. Each book, different books, if you see, each one will follow different kinds of terminologies. I feel latest term that is used is gravitational energy, and I will always be using the term called gravitational energy. So the gravitational energy possessed by the body is 200 Newton meter. So this is the first form of energy, and we will also see other forms of energy. The first form of energy we have seen is gravitational energy. Second is kinetic energy. Third is pressure energy. So we will take the same example I took previously, that is 10 kg of mass was at a height of 2 meters. So how much of gravitational energy that was possessed by the body? Gravitational energy that was possessed by the body is mg z. So mg is the force, z is the distance. So gravitational energy is equal to mg z, and that is equal to 10 into g is also 10 into 2. So 200 Newton meter of gravitational energy. With regard to gravitational energy, with regard to all forms of energy, I will also introduce one more term called head, or gravitational energy head, kinetic energy head, pressure energy head, like that. For all forms of energy, I will introduce 3 more terms by adding a word called head. Now I will talk about what head means. Gravitational energy head means it is gravitational energy possessed by the body per unit weight of that body. So the gravitational energy possessed by this body is 200 Newton meter divided by, what is the weight of this body? 10 kg into 10 meter per second squared. So 200 divided by 100 is again 2. The unit is, if you are seeing, this is Newton meter, this is weight. So the unit for weight is Newton. So Newton gets cancelled and you get a unit to be meters. So gravitational energy head is defined as the gravitational energy possessed by the body per unit weight of the body. So if you see, if you are calculating gravitational energy head of this body, again what you get is, you get just the height of the body. If you just find out the height of the body, then you are able to get gravitational energy head. Next, we will see about kinetic energy. Kinetic energy. So let us assume that we have frictionless surface. We have frictionless surface, and you have a mass m, and you increase its velocity. This is, let us say, distance d, and it is at zero velocity to start with, and you are increasing its velocity to v velocity, and time taken is, in t time, you are increasing the velocity to v within distance d. That means that you have accelerated this mass. So what is the work done for doing this work? So work done is again force into distance, and force, we know that it is rate of change of momentum. Rate of change of momentum is, final momentum is this mass into velocity is final momentum. Initial momentum is 0. It happens with what time? T time. So this is the rate of change of momentum into d. So what is mv dt? Okay, work done is mv d by t. So what is d by t? D by t in this case is distance travelled by this body in time t. D is distance and t is time. So many a time people assume that this distance by time is equal to velocity, and they write that as mv squared. But it should not be done so, because when this process is happening, the velocity is not constant. Velocity to start with is 0, the velocity keeps on increasing, and the velocity reaches to velocity v after passing a distance of d. So to start with velocity is 0, and to end, at the end it has a velocity of v. So d by t will give you average velocity. Average velocity is v by 2. So it is v by 2. That is the reason why its formula is half mv squared. So the formula for kinetic energy is half mv squared. And if you want to find out kinetic energy head, then again kinetic energy head is equal to kinetic energy per unit weight of the body. per weight. So per weight is what? Half mv square. Weight is again mg. So you get v squared by 2g. So for kinetic energy head, this is the formula. Finally, now we will see about pressure energy. Third, pressure energy. So we will now see about what is pressure, what is pressure energy, and also what is pressure energy head. So with regard to pressure, we need to understand these three concepts: pressure, pressure energy, and pressure energy head. So we all know about pressure very well. I have taken a container of a circular cross section. Let us say A is the area of cross section. So I will take a plane, XX plane, and it is at a height of h. So what is the volume of water? Let us say this is the let us say it is filled with water. So what is the volume of water that is above this plane? So volume above this plane is A into h. What is the mass? Mass is mass density into volume. So what is the weight? Weight is rho g a h. So the total weight above this plane is rho g a h. So that means what is the pressure at xx? Pressure is equal to force divided by area. So it is rho g a h divided by area. So you get pressure to be is equal to rho g h. So in order to find out the pressure, you should make use of the formula rho g h. So pressure here is rho g h. So if the pressure at from the top is rho g h, since it is balanced, so the pressure from here also it is rho g h. So in water you should also keep in your mind that pressure at any point is equal in all directions. So in all directions also pressure will be rho g h. So you should also keep in your mind that in pressure calculation only height is used, not the total volume or total weight of the water. So if you take a narrow container of same height, and here also the pressure will be rho g h only. So in order to calculate pressure, if you just find out height of the surface of the water from that location, you will be able to find out the pressure. So in a flowing pipe with water, if you just insert a pipe called, this pipe is called piezometer. So water is flowing. So pressure in this pipe, flowing pipe, can be found out using a a vertical pipe that is inserted like this. So the pressure at this place is equal to, because this standing water is in equilibrium with the flowing water, so pressure of this standing water is equal to the pressure of the flowing water. So if you just find out what is this height, say h, so the pressure of flowing water is rho g h. Rho is mass density. The next concept is pressure energy. So what is pressure energy? Pressure energy is the energy needed to add pressure to the water. So for that I will use this image. Let us assume that we have a very small hole with this cross-sectional area. Let us assume that it is equal to area of hole. Area of hole is, let us assume that it is A, and the length of this length is L, and in this hole, let us assume that we intend to send this particle of water inside this tank, and on the other side in the tank, the height of the water that is standing in the tank is h. So what is the pressure on this side? This is the water particle to be sent inside the tank. And what is the pressure on this side? Pressure on this side is equal to rho g h. So the force on this side is equal to rho g h into E. So force on this side is rho g h A, means how much of force is needed to be given on this side. If there is no friction, then rho g h A plus delta amount of force, delta F, if you are able to give, you will be able to insert this water particle inside. So we can assume that delta F to be negligible. So force needed to push the water inside is also rho g h A only. So what is the work done? To push this water particle inside? That is equal to force into distance. Again, rho g h A L. So work done is rho g h A L. So we have done work of this much to insert into the tank. So what has happened? Our work has got transferred into pressure energy for this water particle, and that pressure energy is stored inside this water. So how much of work we have done per unit weight of water divided by the weight of the water. What is the weight of the water? Weight of the water is A, L is volume, into rho G is the weight. So A, L, rho G, A, L, rho G. So you get only H. So work done per unit weight or pressure energy possessed by the water per unit weight is just H, and that is equal to the weight of the height of the water that is standing above this location. So in order to find out pressure energy head, if you just measure at any point, the height of the surface, then you get a pressure energy head. So now I have talked about three forms of energy. One is kinetic energy, pressure energy, and gravitational energy. So now I will take a pipe in which water is flowing when water is flowing, let us assume that we have a vertical pipe and we have a land surface, and that we call it as datum, and it is flowing with velocity v, and this is h, and this is z. So in a flowing water we can identify three forms of energy. One is gravitational energy. Gravitational energy head. Gravitational energy head is Z. At this location, how much of energy that is being possessed by the water, and that is equal to Z. Kinetic energy head is, already we said that it is V squared by 2G. And sorry, this is not gravitational energy. Yes, this is gravitational energy. And pressure energy head. Pressure energy head is, it is H. So the total energy head is equal to Z plus V squared by 2G plus H. So the total energy possessed by the water per unit weight is equal to Z plus V squared by 2G plus H, and that we will denote it with capital H. So total energy we have denoted with H, and it has three forms of energy. So now we are able to understand that when water is flowing at this place, it is possessing energy. So when it is possessing energy, when it is flowing across this section, energy is also flowing. So how can we estimate how much energy flow? Energy flow per time is how much of water that is going is, let us assume that discharge rate is Q. So Q multiplied by rho into G. So Q multiplied by weight density will give you, this is the weight of water flow. So H, this is weight rate of flow. Okay, weight rate of flow. This is energy per weight. So weight and weight gets cancelled, and energy rate is called power. So power formula is equal to rho Q G H. So with this formula we will be able to find out how much power is getting transferred at this section.